This is Algebra 2, Chapter 3, Section 3, Part B, in which we will continue studying optimization using linear programming. Now, we already know how to get started with linear programming. We know how to graph the inequalities. We know how to find the feasible region. We know how to shade or do the shading. We know how to find the corners, and we know how to plug those in to find max and min. Now we're ready to do the optimization part. That is to say, we're ready to try to find the best situation for a given problem. Typically, you're maximizing profits or minimizing costs. You may be trying to maximize your crop yield, something of that sort. The key to doing an optimization problem is being able to understand what the word problem is talking about. And there are a few important things to look for. These are the questions I will be asking you over and over with these problems. What do you have control over? The things that you have control over are going to be your variables. Okay. If, for example, they tell you that this machine can run for 12 hours a day, it takes 3 hours to make a chair and 4 hours to make a table or something like that. Chairs and tables would be your variables because you get to control how many of these things you make. That would be your variables. What limitations are there? That's going to be the inequalities. That's your constraints. So having 12 hours for that machine to run would be a limitation. And then what are you trying to optimize? If you're trying to optimize making the most profit or the least cost or whatever, that's what your function is going to be about. And remember, with functions, you don't graph those. That's what you plug into at the end. So we're going to tangle with one of these problems to get your feet wet so that you're ready to try to take some on. So we have our dear friend Mackenzie here, who each week can make anywhere from 10 to 25 necklaces and anywhere from 15 to 40 pairs of earrings. If she earns a profit of $3 for each pair of earrings and $5 for each necklace, and she plans to sell at least 30 pieces, how can she maximize her profit? Okay. Let's look at what we've got. What do we have control over? What does she have control over? She has control over making necklaces and earrings. So those are going to be my variables. I called necklaces X and earrings Y. Okay. You could use N and E or whatever. I used X and Y so that it fits with my graphing a little easier. Okay. So those are the variables. What do we have limitations of? Well, we have limitations that she's going to make between 10 to 25 necklaces. So there's going to be an inequality about necklaces. We can make 15 to 40 earrings. So that will be a limitation. And selling at least 30 pieces is also a limitation. What are we trying to optimize? We're trying to make the maximum profit. So profit is where our function comes from. Now, fortunately for you, you have your note sheet in front of you, so you'll have this page to work from. Me, I've got to turn to the next page where I have room to work. Now, we said we have 10 to 25 necklaces. Necklaces represented X, so X is between 10 and 25. 10 is less than or equal to X is less than or equal to 25. We know how to graph that. When X is less than or equal to, or between 10 and 25, that's going to be Here's 10. And here's 25. And it's going to be in between those. Now, earrings needs to be between 15 and 40. Earrings we said was y, so y is between 15 and 40. 15 is less than or equal to y, which is less than or equal to 40. Well, we know how to graph that. Y is 15, goes right through here. Y is 40, goes right through here. Okay. Now this part, we're going to be selling at least 30 pieces. Well, this is where we have to do a little bit of thinking. This means x plus y is going to be greater than 30. The number of necklaces plus the number of earrings has to be greater than 30. And it's greater than because it says at least, so 30 or more would be good. Well, we know how to graph that. Let's get our intercepts. If x is 0, y is 30. If y is 0, x is 30. So we have a line going from 30 to 30. Of course, didn't quite go through 30 on that side, but we can fix that. Okay. Now we have to do our shading. We know we're between 10 and 25. We're between 15 and 40. 0 plus 0 greater than 30 is false. So we're shading this region. And as always, your shading can be just as pretty as mine. Doesn't have to be perfect. Shading with a touchpad isn't always easy. Now we need our profit function. And we said in the problem that she's going to make $5 profit on each necklace plus $3 profit on each pair of earrings. We've got our profits, we've got our function, we've got our region. The next thing we need is our corners. Well, we have a corner at 10 and 40, which when we plug that in, we find out that we got 170 for our profit. We've got a corner at 25 and 40. When we plug that in, we get a profit of 245. At 25 and 15, you get a profit of 170. At 15 and 15, we get a profit of 120. And at 10 and 20, we get a profit of 110. So what should she do to make the most profit? She should make 25 necklaces and 15 pairs of earrings, because that's the one that gave us the maximum. And that makes her a maximum profit of $245. Okay. You have to take it apart in pieces. Figure out what you have control over first, because that will be your variables. Figure out where you are limited on things. Those will be your inequalities. Get those graphed, find your corners. Figure out what you're trying to optimize, make the most of or the least of. That's your function. Once you have your corners, you can plug those into the function and then pick out what they ask for, if they ask for the maximum or the minimum. Okay? It's a bit of a process. It takes time. You're just going to have to stick with it. Don't give up. You can do this. And as always, if you had questions along the way, hopefully you wrote those down. Bring them in with you, and we will see you in class.